In this video, we're going to work our way through problem number 7, part A, on page 480 in the textbook. The stem of the number 7 says, for each of the following sets of pressure and volume data, calculate the missing quantity. Assume that the temperature and the amount of gas remain constant. For part A, V equals 53.2 milliliters at 785 millimeters of mercury, and V at the second part is 700, and that's got three significant figures, millimeters of mercury, so we're trying to find that second V. Since we have pressures in millimeters of mercury and volumes in milliliters, we know that we're going to use Boyle's law for this one, and Boyle's law tells us that the relationship between pressure and volume is inverse, that is, that one of those goes up, the other one is going to go down at the same time, provided that the temperature and the amount of gas that we have in the sample doesn't change. All right, so let's just make a variable table first. They tell us that the volume to start with, I'm going to call that V1, is 53.2 milliliters, so 53.2 milliliters. And the pressure at that time, the same time we measure that one, we'll call that one P1, is 785 millimeters of mercury, 785 millimeters of mercury. And we are to find another volume, we'll call it V2. V2 is what we're looking for. When we change the pressure, so that's P2, the second time we measure the pressure is 700 millimeters of mercury. Okay, and since Boyle's law is a relationship that says that when the pressure goes up, the volume goes down, we could write it something like this, and your graph from your lab should have given you a relationship something like that. It may have been written something like some value of K, V to the minus 1, but that's the same thing. And that's telling us that if we multiply the pressure times the volume for a sample of gas, that it'll equal some value that doesn't change. So we could also say this, if it's P times V equals K, if we took one set of P's and V's, and we took a second set of P's and V's that go together, as long as we don't change the temperature or the amount of gas, we will get the same thing. So Boyle's law says the pressure 1, the volume 1 equals the pressure 2. The volume 2 is a practical way of using that. And in this problem, we are looking for V2, so we're going to do the algebra here. Divide both sides by P2, and that will show us that P1, V1 over P2 will give us a volume. Let's go ahead and put those numbers in down here. That pressure 1 was 785 millimeters of mercury, and we're going to multiply that by the volume originally, which was 53.2 milliliters, and we'll divide that whole thing by the new pressure, which is 700 millimeters of mercury. So when we do this, the millimeters of mercury will cancel out. We'll end up in milliliters, and the value for this is 59.7 milliliters. 59.7. Now let's consider whether that seems reasonable. The pressure went from 785 to 700. It went down. It went down, and this is an inverse relationship, then the volume should go up. Does the volume go up? It does. It goes from 53 to about 60. All right, so there we have a Boyle's law problem.